Remember when we had to explicitly program computers to do everything? Those days are rapidly becoming history. In the next 20 minutes, we're diving into the machine learning revolution that's reshaping everything from your social media feeds to how doctors diagnose cancer. Machine learning isn't just another tech buzzword, it's the driving force behind the most transformative technology revolution since the internet. And it's here to stay. It's the technology behind ChatGPT, AlphaFold, Claude, DALL-E, DeepSeek, and Midjourney. By the end of this video, you'll understand how machines learn, why it matters to your future, and the challenges that come with this powerful technology. Classic programming is like giving your computer a recipe. If user clicks this, then do that. This approach is limited in flexibility and requires programmers to anticipate every scenario. Machine learning fundamentally changes this approach. Instead of telling the computer how to solve problems, you show it what solved problems look like, and it figures out the method itself. Think of it this way. Traditional programming is like teaching someone to bake by giving them precise instructions. Machine learning is like showing them thousands of perfect cakes and letting them figure out the recipe on their own. This is why facial recognition works even when lighting conditions change, and why recommendation systems can predict what content might interest you next. Let's talk about the essential ingredient, training data. All machine learning systems are built on collections of examples. Want to recognize cats? The algorithm needs thousands of cat pictures. Want to predict stock prices? It requires years of stock market data. The system learns patterns from these examples and applies them to new situations. The quality of your data directly determines the quality of your model. Poor or biased data leads to poor or biased results. This principle of garbage in, garbage out is fundamental to understanding machine learning limitations. This is also why data has become so valuable to companies and why privacy considerations are increasingly important as more systems rely on personal data for training. Machine learning comes in three main flavors, each with its own approach to learning from data. First, we have supervised learning, the most common type and the type behind most of the AI you know. Here, we train models on labeled data. Think of it as learning with an answer key. We show the model inputs and their correct outputs, and it learns to predict outputs for new inputs. This powers everything from spam filters to medical diagnosis algorithms. Next is unsupervised learning, where models find patterns in unlabeled data. There's no answer key, the algorithm has to discover structure on its own. It's like giving someone a pile of objects and asking them to sort them by similarity without instructions. So where for supervised learning, we would say, these are apples and these are melons, please figure out what makes them different. Here we say, here are some fruits, please sort them by similarity. This helps with customer segmentation, recommendation systems, and automatic photo organization. Finally, there's reinforcement learning, which works through trial and error. The model learns by taking actions in an environment and receiving rewards or penalties. It's similar to how we might train a pet. Good behavior gets rewarded. This approach mastered games like chess and Go, and now drives autonomous vehicles and robotics. Neural networks are the powerhouse behind most modern AI breakthroughs, inspired by how our brains work. At their core, neural networks are made of digital neurons organized in layers. Each neuron takes multiple input numbers from other neurons, combines them in different proportions by applying so-called weights to each input, and produces an output that gets passed to the next layer. During training, these weights get adjusted to minimize errors. Each neuron is individually deciding how much of each input to use to produce the expected output. What makes neural networks, and especially deep learning, special is their ability to handle complex, nonlinear relationships in data. It does this by combining many layers of neurons, each layer adding a literal layer of complexity. A single neuron might detect simple patterns like edges in an image. But when you stack many layers together, what we call deep learning, the network can recognize cats, cars, or cancer cells. Deep learning is just neural networks with many layers. The deeper the network, the more complex patterns it can recognize. This depth is what powers ChatGPT's ability to write essays, DALL-E's image generation, and the ability of self-driving cars to navigate complex environments. Machine learning is no longer confined to research labs. It's embedded in your daily routine, often without you noticing. When you scroll through social media, algorithms analyze your behavior to determine which content keeps you engaged longest. Your email client filters spam with remarkable accuracy. Your smart speaker understands your voice commands, despite background noise or your accent. Even more personal is your smartphone keyboard, which predicts your next word based on billions of text conversations and your own typing patterns. Notice how it learns your unique phrases and writing style over time? That's machine learning adapting to you specifically. These examples might seem trivial, but they represent a fundamental shift in how technology serves us. Instead of adapting to rigid software, the software now adapts to us, learning our preferences, habits, and needs. In healthcare, machine learning isn't just convenient, it's saving lives. Algorithms now detect early signs of diseases that human doctors might miss in medical images. Consider cancer detection. Deep learning models can now spot early stage lung cancer in CT scans with greater accuracy than experienced radiologists. One study showed AI catching cancers up to a year earlier than traditional methods, dramatically improving survival rates. Beyond diagnostics, machine learning optimizes treatment plans based on millions of previous cases, predicts patient readmission risks, and even assists in drug discovery. Researchers recently used AI to identify a new antibiotic effective against drug-resistant bacteria, a process that would have taken years using conventional methods. Perhaps the most groundbreaking AI contribution to healthcare has been DeepMind's AlphaFold, which revolutionized protein structure prediction. The system can accurately determine a protein's 3D shape from its amino acid sequence alone, a challenge that had stumped scientists for decades, including myself, who worked on this problem for my PhD thesis. This breakthrough earned its creators the 2023 Nobel Prize in Chemistry, marking the first time AI research has received this prestigious recognition. AlphaFold's impact is profound. By understanding protein structures, researchers can better develop targeted medications, understand disease mechanisms, and accelerate drug discovery for conditions ranging from cancer to infectious diseases. This single technological leap is projected to accelerate medical research and drug development by decades, compressing what would have been centuries of manual protein mapping into just a few years. The most exciting aspect is how these technologies democratize expert-level healthcare. Even in regions with few specialists, AI-assisted diagnostics can provide accurate analysis, helping to close critical gaps in global healthcare access. Machine learning is becoming a powerful ally in our fight against climate change by making renewable energy more efficient and reliable. One of the biggest challenges with renewable energy sources, like solar and wind, is their variability. The sun doesn't always shine, and the wind doesn't always blow. Machine learning algorithms now predict this variability with remarkable precision, allowing power grid operators to balance supply and demand effectively. Google's DeepMind demonstrated this by reducing the energy used for cooling their data centers by 40% through ML optimization. Similarly, smart grids use predictive algorithms to distribute power more efficiently across cities, reducing waste and preventing outages. Beyond energy management, ML helps climate scientists process vast amounts of environmental data to improve climate models. These enhanced models provide more accurate predictions of climate patterns, helping communities prepare for changes and policymakers make informed decisions. From optimizing building energy usage to designing more efficient materials for solar panels, machine learning is accelerating our transition to a more sustainable future, and doing it faster than traditional approaches ever could. The AI revolution is reshaping the job market in profound ways, creating new opportunities while automating routine tasks. New roles that didn't exist 5 years ago are now in high demand. Prompt engineers design the instructions that guide large language models. AI ethicists ensure systems are developed responsibly. MLOps specialists maintain and deploy machine learning systems at scale. Meanwhile, automation is changing traditional roles. Legal professionals now use AI to review documents, freeing them to focus on strategy. Marketers leverage ML to analyze campaign performance and optimize messaging. Healthcare providers use AI assistants to handle administrative tasks, giving them more time with patients. Jobs aren't simply disappearing, they're evolving. The most valuable skills now combine domain expertise with an understanding of AI capabilities. Those who can collaborate effectively with ML systems, knowing when to trust them and when to question them, will thrive in this new landscape. Every click, purchase, and interaction you have online generates data that helps these systems improve. When you correct your phone's autocorrect, you're training its text prediction. When you click on a recommended product, you're reinforcing the recommendation algorithm. The difference from oil is that data is continuously generated. As you use services, you create more data, which improves the services, which encourages more usage, creating a powerful feedback loop that entrenches successful AI systems. This data dependence explains why free services ask for so much information and why privacy has become such a critical concern in the digital age. This is also the origin of the expression, if you're not paying for the product, you are the product. The machine learning revolution presents us with a fundamental trade-off: personalization versus privacy. More personalized experiences require more personal data. Your music app suggests songs you'll love because it knows your listening history. Your Maps app provides accurate travel times because it tracks location patterns. Your virtual assistant becomes more helpful as it learns your preferences and habits. However, this personalization comes at a cost. Detailed profiles of our behaviors, preferences, and even personalities are being assembled by the systems we use. This raises questions about who has access to this information and how it might be used beyond its original purpose. Differential privacy and federated learning are emerging techniques that aim to balance these concerns. These approaches allow models to learn from your data without directly accessing or storing it. Your phone, for instance, might update an AI model locally and only share the anonymous improvements rather than your raw data. Even the most advanced AI models sometimes confidently present false information, a phenomenon known as hallucination. Large language models like GPT-4 don't actually understand the world. They predict text patterns based on what they've seen during training. This leads to a strange situation where they can generate plausible sounding but entirely fabricated information, from non-existent research papers to made-up historical events. This limitation becomes dangerous when these systems are trusted as authoritative sources. A lawyer recently cited non-existent legal cases generated by an AI assistant, leading to professional embarrassment and potential legal consequences. Understanding this limitation is crucial for responsible use of AI tools. The most effective approaches combine AI's ability to process vast amounts of information with human judgment to verify critical facts and logic. Machine learning is creating problems that only machine learning can solve, leading to an AI arms race in areas like deepfake technology. Deepfakes, synthetically generated media that can make people appear to say or do things they never did, have evolved rapidly. Early deepfakes were easily spotted due to visual artifacts, but current technology can create videos nearly indistinguishable from genuine footage. In response, researchers are developing increasingly sophisticated detection algorithms that identify subtle inconsistencies humans might miss. Unusual blinking patterns, microexpressions, or pixel-level artifacts. This technological arms race illustrates a broader pattern in AI development. New capabilities create new challenges that require new solutions. As generative AI becomes more powerful, we face questions about media authenticity, misinformation, and the evolving nature of digital evidence. The deepfake phenomenon highlights how machine learning is both problem and solution, requiring us to think carefully about governance, verification systems, and digital literacy in an age where seeing is no longer believing. The pace of AI advancement shows no signs of slowing, with several breakthroughs reshaping the landscape in 2025. Frontier models like DeepSeek, Grok, and Claude Sonnet and Manus have further blurred the line between human and machine creativity. While they don't possess true understanding or consciousness, their ability to generate novel content, from code to art to business strategies, has transformed creative workflows across industries. More significant is the rise of multimodal models that seamlessly work across different types of data. These systems don't just process text or images separately, they understand relationships between words, visuals, audio, and even physical data from sensors. This integration enables more natural human-computer interaction and opens new applications previously thought impossible. We're also seeing specialized AI systems reaching expert-level performance in domains requiring deep technical knowledge. From designing new materials with specific properties to optimizing complex supply chains, these systems augment human expertise in ways that significantly accelerate progress. The breakthrough that may matter most, however, is improved explainability. AI systems that can articulate their reasoning process, making their decisions more transparent and trustworthy for critical applications. The convergence of machine learning and augmented reality is creating experiences that seamlessly blend digital intelligence with our physical world. AR glasses now use computer vision algorithms to recognize objects, buildings, and people in your field of view, instantly overlaying relevant information. These systems understand your environment in real time, identifying everything from plant species to architectural styles to forgotten acquaintances. Machine learning enables these devices to be contextually aware, understanding not just what you're looking at, but why you might be interested in it. Your preferences, history, and current needs shape what information appears in your field of view. This integration extends beyond visual recognition. Natural language processing allows for conversational interaction with your surroundings. Point to a restaurant and ask about wait times, gesture toward a product and request comparison pricing, or look at a building and inquire about its history. As machine learning reshapes our world, you have an important role to play beyond being a passive consumer of AI technology. Every day, you make choices that influence how these systems develop. The apps you use, the data you share, the misinformation you choose not to spread, all contribute to the digital ecosystem that AI systems learn from. Your feedback matters tremendously. When you report a problematic AI generated result, flag biased recommendations, or provide explicit feedback, you're helping improve these systems for everyone. More fundamentally, your critical thinking skills become increasingly valuable. Knowing when to trust AI outputs and when to question them requires judgment that machines themselves don't possess yet. The ability to verify information, recognize limitations, and apply ethical considerations to AI use will differentiate informed participants from passive consumers. But you can take an even more active role by learning machine learning yourself. In 2025, ML skills offer unique advantages compared to traditional programming alone. The demand for this expertise remains extraordinarily high, with ML specialists consistently commanding premium salaries, often 20 to 30% higher than traditional software roles. Unlike conventional programming, which can sometimes be outsourced, ML requires deep contextual understanding and domain expertise. This makes these skills more resistant to outsourcing and automation. The ability to frame problems in terms machines can learn from is becoming as valuable as writing code itself. Machine learning expertise also offers remarkable versatility across industries. Financial institutions need risk assessment models, healthcare requires diagnostic tools. Manufacturing benefits from predictive maintenance. Entertainment uses recommendation systems. This cross-industry applicability means your skills remain valuable even during sector-specific downturns. This is where almost all industries are moving. Machine learning is everywhere. Even if you don't become a dedicated ML engineer, understanding these technologies makes you more effective in adjacent roles. Product managers who understand ML capabilities build better products. UX designers who grasp model limitations create more effective interfaces. Business analysts who comprehend data requirements make more informed strategic decisions. The good news? You don't need a PhD to start. Online courses, bootcamps, or even tutorials on my YouTube channel can build practical skills that immediately create value. The field rewards those who can solve real problems, not just those with theoretical knowledge. By understanding the basics of how these systems work, you're better equipped to advocate for responsible AI development, protect your digital rights, and shape how these technologies integrate into society. We've covered a lot of ground, from how machines learn patterns to how they're transforming industries and creating new ethical challenges. Machine learning isn't just another technology trend. It's a fundamental shift in how we build tools and solve problems. Instead of explicitly programming solutions, we're creating systems that learn to find solutions themselves. The implications are profound. Healthcare becomes more precise and accessible. Climate challenges receive data-driven solutions. Jobs evolve to leverage uniquely human skills alongside AI capabilities. Yet challenges remain. We must address bias, ensure privacy, manage misinformation, and create governance structures that channel this powerful technology toward beneficial outcomes. As we've discussed, learning machine learning offers tremendous value in today's job market. Whether you aim to specialize in AI development or simply want to stay relevant in your current field, understanding these technologies provides a competitive advantage that will only grow in the coming years. The cross-industry demand for these skills offers both job security and intellectual stimulation. If you're interested in diving deeper, there are excellent resources to continue your learning journey. There are plenty of free resources on how to learn machine learning on the internet, including on this very channel, but also on other YouTube channels and other platforms like Coursera. Whatever path you choose, staying informed about machine learning is no longer optional. It's essential for navigating our increasingly AI-augmented world. Thanks for watching, and remember, in the age of artificial intelligence, human intelligence remains our most valuable resource.